spraying the sprinklers that are spraying at a given diameter. And the diameter also corresponds to the planting distance of the crops, so that they will be weighted very well. And the thing is moving slowly so as to remove or to bring out the quantity of water that is needed in order to reach the crop root zone effectively. It's the pressure that rotates. We don't need the pump. It's the pressure that rotates, pressure from the supply. Can be in two ways. We are hanging it down. If you want, you can hang it up. So in that case, it makes a curve coming down. It will go up and curve downwards like a projectile. So yeah, but this one is getting stressed like this. As you can see the ridges, water is spraying. This tower, this is only one tower. We have provision for increasing. If you want to have 2 or 3 towers, there's provision at the end. Increase the tower. We have only 1 tower here. If you want to increase, you're losing this. You remove it, then attach the second tower. As you can see, it's removable. You attach the second tower. You have to loosen this to remove this drive mechanism to put at the end. So that is why we use the knot to fasten it. So it's removable. It's detachable. You can detach it and attach it to the last tower. When you put it at the last tower, so that you'll be able to drive. The drive mechanism is made up of 2 tires. As you can see, the driver and the driven. You have the motor, electric motor, various sizes. You choose the one you want that will give you exactly the speed you want. And then we have an axle. This is a motor axle. This is a motor axle. And this is a transmission. This transmission changes the direction of rotation at 90 degrees. Yeah, from the motor to the axle and to the sprockets that drives the driver.
These are for distribution uniformity and application efficiency experiment. You want to know the volume of water that will be captured by these cars. Measuring cylinder is there. After I've collected the water from these cars, I will use the measuring cylinder to now measure the amount of water, the total quantity of water that each catch can has captured. So the pressure. Yeah. And then this one surely is supposed to be more than all of them, but it's less. This one is even less.
Okay.
The catch cans.
Okay.
And the way you arrange these catch cans, because of the pressure from the sprinklers, you hook them on these things so that they don't fall away. Yes.
Okay.
They are the same size of catch cans. You put them at the same height from the ground level.
Okay. Wow.
Measuring cylinder.
Okay.
To measure the quantity of water that has been trapped at each catch can.
Okay.
And that will help to know the depth of water, whether to be able to get to the crop root zone or not, the depth of irrigation. Whether it will be uniform, because if it's uniform, then your uniformity coefficient will be high. But if it's low, your uniformity coefficient will be low. And as such, it may create deficit in your irrigation you are doing. The crops may not get the required volume of water for them to do well. So that's the essence, as he has explained earlier.
Okay. Sir, may we know the degree of rotation of this your invention? Okay, 360 degrees.
Goes round. 360.
Just like Prof was saying, when you want to capture this. This is a one-span center pivot irrigation system. One tower. From the length of this is one tower. This is 7.5 meters.
Okay.
The length is 7.5 meters. And it's carrying 3 sprinklers.
Okay.
This triangular sections are called support. They support the tower. And this is a tension string. It helps to hold the main, that main that is supplying the water in that position so that it doesn't fail, so that there will be no failure.
What is making this tower to rotate without the wire being cut off.
You can see the system here.
Then come to the pivot section.
Okay.
And this, as the name implies, center pivot. This is the center of the whole thing. So this is at the center to all the. If you draw a circle,
Yes.
this is the center of the circle that it rotates. So this tripod, 1, 2, 3 legs, is the support. This is about 2 meters high. Yeah. This is the cable supplying the power. This from the source. If it comes to the source, in order to go around, the wire will twist. So to avoid that twist, we provided a brush. Okay, we brought a brush which connects the wire separately, and the electricity, the current is transferred from this brush to this one. Then the incoming or the outgoing cable picks it from the second brush, which goes to drive the electric motor.
Wow.
And for the drive mechanism to go on.
Okay.
This is our water source. You can see the supply, the tank. This is supposed to be the water source. The tank is high, about 5 meters, so as to get our water flow by gravity.
And why the tank is 5 meters is because we actually choose the height of our center pivot is 2 meters. So we're thinking that the difference in the head of 3 meters will give us the pressure that will rotate those sprinklers.
So the water is
The size of the tank is 3,000 liters.
wow.
Yes, 3,000 liters.
The main pipe carrying the water, the main supply, is buried on the ground to the center pivot. We make sure that the depth of burying is beyond the plowing depth. If a tractor is going round, tractor will not touch it. It's below the depth, so it can go freely. And the cable itself is very depth. This is a control. This is why you need to control the speed of rotation. This controls the speed of rotation, as you can see. And why the speed should be controlled? For you to have enough amount of irrigated water. Water for your irrigation. So, that's it.
Let's go.
Okay, this is the control switch, the control box. This is the on and off button. This is the speed regulator.
Right.
We have number 1, the speed 1 to 7 speed. We're using 5 to 7 because 1 to 4 is actually too slow to move that electric motor. So from 5 to 7, you see that there's a difference in the rotation of the pivot mechanism.
This is Solomon Akazwa.
Okay.
He's an expert in fabrication. He's our link man in this work. He has been helping us to fabricate the concept we have, and he's doing it perfectly well.
So what do you have to say about this machine, Mr. Solomon?
Well, actually, I understand that it doesn't take only one person to fabricate this.
Yes.
You have to bring a whole team of engineers together to put this together. Actually, we are fabricating this equipment based on what we have here on ground. As you can see, this is a rear axle. This is a transmission,
Okay.
gear motor, and as you can see, this is a tricycle tire
Wow.
and steering spiral connection. This is what we have here on ground so that it can make this equipment cheaper for us to fabricate.
All right. Thank you very much. Have you ever done this kind of fabrication before?
Not really. This is the first time to fabricate such kind of equipment.
Has this ever been done in Nigeria before?
Not really, I don't think so.
Wow. That's great. This is a good invention, a great invention. Thank you very much, sir.
So it is that is the point. Come here. So take it come here. So if you put it there, that is what if another one is here, even if it's not overlapping, you see that here too is there's more water. So you have the same capture the same water. This is 200 kg. The whole of this thing is less than 150 kg. And this is the weight that this motor can also carry. So when you are talking of extension now, if you are extending it now, the weight increases. That new tower alone is a new weight. You look at the motor that will carry that new weight. The rest it will not move. It will not move it. But this motor now, even if you go and stand on it, it will move you. You really enjoy it more.
Yes.
You see now, the level of penetration assumption is
Yeah,
this. So maybe
What depth did you get that time?
No, that allow you to stay in one place for a long time. we got 7 centimeters. Yes. This one cannot even give up to
unless if